Hello team, today's challenge is Narcissistic Number, where we're given a number and we need to figure out if the number of digits as the power to each digit totals to the original number, which is kind of confusing. But you see here 153 has 3 digits, right? 1, 5, and 3. And we raise each to the power of 3, so 1 to the power of 3, 5 to the 3, 3 to 3, and in theory that should come out to 153. So in this case, they would consider that to be narcissistic. To get this done, we can go over to our code and figure out, the first step is to figure out how many digits are in this number, okay? For that, you will see a very common loop where we go something like digits and set that equal to n, and then we turn it into a string because that allows us to operate on individual characters of that string. It's no longer a number, it's characters, which means that we can split on it, splitting on everything, and then mapping. And for this, we convert it all back to a number. Kind of weird, right? Like, it was a number, we made it a string so that we could do some work on it, and then we turned it back into a number. That's the whole thing there, okay? Down here, we want our total, okay? And this is actually what we will be doing right here, where we compare the number to total, okay? So total is going to be equal to the digits, which is currently an array now, right? Because we mapped over it, we didn't join them back up. So digits dot reduce, reduce being my favorite way to sum up a bunch of numbers, okay? In this case, we have a little extra work, but we'll figure that out. So the accumulator, the current, in this case, we need to type index in here, but we aren't going to use it. I'll talk about that in a second. Because I want the array, okay? Could we just use digits instead of array? Yes, they are actually the exact same thing, right? But if I ever found that this callback function was getting too big, I could extract it somewhere and test it by itself and then just call it here. And in order to do that, I would need array, right? Because I can't pass digits in by magic if it's somewhere else. So array is where it's at. If because we need index, or because we need index to be in the arguments, but we aren't using it, start it with an underscore. And that tells the linter or TypeScript or hopefully whatever else you're using that, yes, I know I added this. No, I'm not going to use it today, right? That's kind of what we're saying, which is why it went back to stark white like that, and we can get it done. Now inside of here, I set 0 as our initial argument because we're running up a total. And this is what I love about reduce. I can throw a bunch of information at it, and what I get out can be just that one thing that we need to send it out the door, okay? So in this case, we are going to return the accumulator plus current, okay? And current is going to be raised to the power of array dot length. Right? That's really the only reason that I needed an array in there. At which point this works, okay? And it works just that fast. So we got the number of digits then, or we actually split into digits, not the number of digits, but split into digits. And then we iterated on those digits to create our total, which we use for comparison, okay? There are 2 loops in here. So we have the map, we have the reduce. We're also calling a bunch of other methods in here, right? There's stuff going on. Could we get rid of map? Yes, we could, because current will now be a string, but we can do stuff. I'm pretty sure that it's the red squiggly line is because we're trying to put a string on array.length and then convert it to a number. I'm not really sure, but the secret here is to wrap it in brackets, and it works. But we can clean this up and make it even faster. Right now we're getting around 900,000 ops per second, at least on my machine. And we can make it much, much faster by doing something else, okay? So I'm going to leave total in here. I'm going to get rid of all of this. The first thing that I want to do is find out what my digit count is. And for that, I'm going to call it power. So power, just like this, and set it equal to math dot log 10 n, okay? If you can imagine this, let's say we had, the number was 1,000, okay? If I pass 1,000 into log 10, it's going to return 3. For me, it's helpful to note that there are 3 zeros, it's returning 3. That makes sense, at least for anything divisible by, that starts with a 1 and is divisible by 10, right? Hopefully that's making sense. But 10 times 10 is 100, times 10, 1,000. Brilliant. Okay, we get that math. So this is going to return a number that I use to raise this to the power of, right? The challenge here is that our n isn't a 10 number, right? It doesn't start with 1 and end with 0. It just doesn't. It could be anything, which means that this one right here is a float, right? And we don't want to float. We just want to know how many characters there are. Well, we already know, at least if it was 1,000, we know that this would return 3. We add 1 to it to get 4. Excellent. So we can do that same thing right here. We're going to wrap this up and go math.floor. I am messing up my capitals. There we go. Math.floor, just like this. That gives us this, right? The 3 zeros. And then we add 1. Extra characters. Done. Okay. So all of this tells us how many characters or how many digits are in this string. Okay, a fancy bit of math that tells us how many digits, which means that now we can do other stuff. The next step, not a const, but a let, because we are going to change this, is going to be the original number, and we're going to set that equal to n. If we change n, right, then down here, n will be completely different, which means that our conditional won't work. So we need something else that we can operate on. I'm calling it a ridge. Maybe that's a terrible name. I don't know. Okay. The next thing is total. Okay. Setting that to 0, just like we had way up here in the reduce, right? We start at 0. We're going to start at 0 here. Now, a while loop. Okay. While original number is greater than 0, we are going to do stuff. What are we going to do? Well, we're going to set the total plus equals all this stuff, okay? And it's going to be the original number modulo modulo 10, okay? There's a reason for that, raised to the power. So let me come back to that. Hold on a second. Let me finish the next line, and then I will explain this, okay? So original is math.floor. And we're kind of doing the same thing here, right? It's going to be original divided by 10, and we get the floor of it, okay? Or we get the whole number. We don't want the floating number, okay? These two lines make this work, but the explanation about why, right? That's the important thing. So let's take the number 123, okay? 123 is our number that we passed in up here, and we are going to run through this loop using 123. So the first step is the original number 123 modulo 10. Okay, well, that's going to give us 12 remainder 3. Technically, it's going to give us that 3. Okay, that 3 raised to the power of 3, because it's 123, 3 digits, right? Which is 27. Okay, 3 times 3 times 3, 27. So we add that to total, and then we move down here and we go, okay, the original divided by 10 is going to give us this floating point number, 12.3, and then we floor it. So we get rid of everything after the decimal, okay? Leaving us with 12. So now it's not 123, it's just 12, and it's still bigger than 0, so we come back in and we do the same thing. 12 modulo 10 is 1 remainder 2, so it's actually 2 to the power of 3. 2 times 2 times 2 is 8, right? We add that to total, and then we go original divided by 10, so that gives us 1.2, and we floor it. Okay, we get rid of everything after the decimal. Excellent. That becomes our original number. It's still bigger than 0, so one more time, it's going to be 0 remainder 1, so 1 to the power of anything is still 1, right? And then down here we go original divided by 1, which gives us 0.1, right? And then, of course, we floor it, which gives us 0. 0 is equal to, it's not greater than, so we exit the loop, right? So we are constantly peeling off the final digit and doing stuff with it using this method, which gives us this. And it is fast, okay? So compared to this was around 900,000 ops per second. This is over 3 million ops per second, okay? So it looks like this, where we have those two things, right? That's our split on our map and our reduce, just like this, compared to just using math, which has been around since the beginning of JavaScript, pretty much, right? And you can see, at least on my machine, it depends on the machine, but on my machine right now, 900,000 ops compared to 3 million ops. So some pretty good stuff there. And all we had to do was lean into this log 10. I think this is the second time we've seen that. So quickly becoming very handy for some of these challenges, okay? So bringing it home, we started out with doing a very traditional 2-string split map, right? So we turned it into a string, we did stuff, turned it back into a number, and then we used all of that information to sum it up and do our comparison. And then we took on the challenge of using just math. So down in here, it's all just math at this point, right? Kind of amazing that way to figure it all out. And along with this while loop, made it super, super fast, right? Again, because it's a while loop, it'll depend on the numbers. Like, I'm sure it would slow down if it was in the millions, right? If your number was, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, or something like that, right? I'm making numbers up now. I don't really know. It's worth a try, right? You can try that on your own. Let me know what you find. But these are the solutions today. Again, not every solution, just hopefully a couple decent solutions, right? Let me know in the comments if you like it, if you hate it, which one you like. And of course, if you found a different solution that you want to share, right? Let me know all that stuff. Otherwise, for today, this has been Narcissistic Number, and I will see you tomorrow.